Hi, I'm Caleb Gardner, your instructor at SLCC. Our section, this is Math 83, section L24, and here we go. Our first lesson that we're going to be covering this semester is multiplication and division with fractions. So in order to start, we first need to go over some key vocabulary. So let's introduce a few vocabulary words. The vocabulary word of in math means multiply. So I could say, what is 1/5 of 20? And you would multiply those two numbers. We'll do that in a minute. I just wanted to introduce the fact that of means multiply. All right, let us go ahead and go over another vocabulary term. Reciprocal. Let me spell that for you. R-E-C-I-P-R-O-C-A-L. Reciprocal. Reciprocal literally means to just take a fraction and flip it upside down. So if I've got 2/3, the reciprocal will be 3/2. Okay, so the reciprocal, these are not actually equal to each other, right? 2/3 just doesn't equal 3/2, but the reciprocal is 3/2. Okay, so let's continue. One more special case for a reciprocal would be if I gave you a whole number like 5. An integer like 5. The reciprocal of 5, before we can find the reciprocal, we need to recognize that 5 has the same value as 5/1. 5/1, now we can take the reciprocal. So when we flip it upside down, the reciprocal is 1/5. So that would be our reciprocal. Okay, let's continue. So we've introduced the word of meaning multiplication, and we've introduced the reciprocal as meaning to just simply flip the fraction upside down. Now, both of those are going to be critical as we go throughout this lesson. All right, let's go ahead and use some of. Here we go. What is 1/5 of 20? This will be our first example. That should be an E. All right, our first example, what is 1/5 of 20? In order to multiply, we first have to rewrite this as 1/5 times, all right, we're going to use a dot to represent multiplication, 20, but I'm going to prefer that we take this 20 and put it over 1 so that we have a fraction times another fraction. Okay, let me make a couple of points here. First of all, many of you are probably thinking common denominator, right? No, we don't have to use a common denominator whenever we multiply or divide. We only have to use that concept, common denominator concept, whenever we add or subtract fractions. That's a different lesson, so not this lesson. Moving on. All right, so there are two ways to multiply this. I'm going to show you this. One of the easiest, I guess, the simplest way is to simply multiply straight across. 1 times 20 is 20. And 5 times 1 is 5. Okay, we're not finished. Our last step is to reduce. Another vocabulary word, right? So let's talk about reduce. To reduce, or reducing. To reduce is to simplify. Let me get on this side where you may be able to see. To reduce is to simplify this fraction. So what we're going to be doing is we're going to be looking for a number that is a factor. That's another vocabulary word. We'll talk about that a little bit more later. A factor that goes, a number that divides into both 20 and 5. Example, the number 5. 5 divides into 20. And 5 also divides into 5. See, 5 goes into 20 and it goes into 5. So our final answer, 20 divided by 5 is 4. 5 divided by itself, anything divided by itself, is 1. All right, so that's our answer. However, this could be simplified even further. 4 divided by 1, or 4/1, is just 4. So 1/5 of 20 is 4. Okay, So let's continue. All right, so let us talk now about, let's do another example, but this time instead of, actually, hold on a second. Let me make sure I introduce all the vocabulary. Okay, I'm going to introduce, what I'm going to do is I'm going to pull up Hawks right now because you're going to be using Hawks, right? So let's pull up Hawks. Actually, I don't have to do it. I got my, my brother's helping me out today. There we go. All right, so now you should be able to see, I'm about to say, I hope they can't see that. You should be able to see an example, 15/8 divided by 3. Very straightforward, 15/8 divided by 3. The directions say find the following quotient. Quotient just means the answer to a division problem. Then reduce to lowest terms. Well, we just practiced reducing. We're going to practice again. I'm going to go ahead and write the problem down, and then we'll switch the screen back over so that you can, there it is. Okay, so 15/8 divided by 3. First of all, let's remind ourselves that this 3 should have a 1 under it, so it can be 15/8 divided by 3/1, because when multiplying, dividing, even adding or subtracting, it's better to use a fraction with another fraction. So we can force 3 to be 3/1, which has the same value as 3. So we're not changing the value, just the way it looks. All right, so here's the rule. So you might want to write this rule down. When dividing, we want to keep the first fraction, change the division sign to multiplication, and then take the reciprocal of the second fraction. Or some would say the denominator, because it is. So the reciprocal of 3/1, we've already learned what a reciprocal is, right? Just flip it upside down. 1/3. Okay. So 15/8 times 1/3. We just learned how to multiply on our last example. So here we go. Let me rewind backwards. Division needs to be converted to multiplication in order to be successful. The only way to do that is to keep the first fraction the same, change our division symbol to multiplication, and finally reciprocate or take the reciprocal of the second fraction. Let's solve this now by multiplying. Multiply straight across. 15 times 1 is 15. And 8 times 3 is 24. All right. Now we need to check and see if we can reduce. Is there any number that divides into 24, nice and clean like, and also into 15? The answer is yes. That is. So we're going to reduce by 3. 15 divided by 3 is 5. And 24 divided by 3 is 8. We can't reduce any further because both of these numbers they no longer have anything in common that they can be divided into both of them. I apologize for choking on my words. I want to show you something else though, with the same problem. So check this out. Let's backtrack just a little bit. When we were on this step, 15/8 times 1/3, I told you earlier that there's another way to multiply. So I'm going to show this to you, then I'm going to give you the freedom to pick and choose which you prefer. Okay, so earlier we practiced, and even right here, we practiced reducing, right? We picked a number that reduces both the 15 and the 24. You don't actually have to write this divided by 3 step. You can do it in your head if you want to. What we could have done also is, we could have also reduced as we were doing it divided by 3, right? 15 divided by 3 is 5. 24 divided by 3 is 8. See how we kind of just cancel and then reduce. Cancel might be the wrong word, but we'll see. Moving on. 15/8, the 15 and the 8 cannot reduce. They don't have anything in common. 15 is 3 times 5, 8 is 2 times 4. So there's nothing that they can reduce by. However, one rule that a lot of people don't realize is when you reduce, you can reduce, this only works with multiplication. You can reduce anything on top with anything on the bottom. All right, so anything in the numerator can reduce with anything in the denominator. So in other words, what I'm saying is this 15 and this 3 can reduce right now. So 15 and 3 reduce by 3. 15 divided by 3, we said is 5. So the 5 will replace the 15. 3 divided by 3 is 1. So the 1 will replace the 3. So now we have 5/8 times 1 over 1. Well, that's easy, right? 5 times 1. So in this situation, what we did is we reduced first, then we multiply. 5 times 1 is 5. 8 times 1 is 8. So again, we reduce first, then multiply. And of course, the first way I taught it was to multiply first, then reduce. With multiplication, you're allowed to do that. You can go in either direction. Personally, I prefer to reduce first. I know other people who prefer to go the opposite direction and multiply first. Doesn't matter. Notice we got the same answer. All right, so we're going to switch back to the Hawk screen now so that you can see the next example. While I erase this. There it is. Skip it, please. All right, next example, 1/8 of 1/7. Find 1/8 of 1/7. I got it. All right, so we remember what we say of means. Of means multiply. So 1/8 times 1/7. That's what we're going to be working out. Okay. Let me remind you, or maybe let me state this for the first time. Another way to write multiplication is to write it like this. Notice there's no symbol here. Since there's no plus or minus here, this means to multiply. So it's just another way to write the same thing. But for the sake of comfort, since you've seen it this way, being consistent, there it is. Now, when we multiply, remember we want to try to reduce and then multiply, or vice versa. Trying to reduce here. 1 doesn't reduce with anything. That was funny. It kind of glitched on me a little bit. Okay. Sorry, I'm talking. Anyway, moving on. And the 8 can't reduce with the 1, or the 7 also can't reduce with 1. And we cannot ever reduce side to side. So even if 8 and 7 were numbers that could reduce with each other, we still can't go side to side. It has to be 1 in the numerator with 1 in the denominator. So there's no reducing here. Let's just simply multiply. 1 times 1, that's easy. 8 times 7 is 56. And our final answer is 1 over 56. I'm sure there'll be some kind of way that you guys can pause this if necessary. I'll do this right here. Muchas gracias. All right, moving on. Next example. So what happens when we multiply by 0? I want you to notice something. Notice the directions. They say multiply and reduce to lowest terms. If the product is undefined, write undefined in the answer box. We're going to talk about that in just a second. First, let me write down this example and let's talk about it. This is actually the easiest question you might ever get in a math class. That was good. 1/3 times 0. Yo, anything times 0. This is a rule. Write it down if you need to. Actually, write it down. 1/3 times 0. Anything times 0. Let me write that down. Anything times 0. The answer is just 0. Anything times 0. So what's 1/3 times 0? 0. What's x times 0? 0. What is, how about this one? My favorite, smiley face times 0. Yeah, still 0. Anything times 0 is 0. So that was a very simple question to answer. I'm going to take a second now and talk about that undefined word. Okay. Let's talk about that. So we talked about what happens when you multiply by 0. Now the 0 could be in the front, right? 0 times anything, or anything times 0 is always 0, it doesn't matter. Let's talk about division with 0. There's two situations here. We can have 0 divided by a number, like 5, or we can have a number like 5 divided by 0, right? So those are two different situations. Let me also say that 0 divided by 5 could be rewritten as 0 over 5, because this is the exact same statement, just written in a different format. This would be written as 5 divided by 0. Now let's talk about the difference between the two. 0 divided by 5 is 0. If the 0 is listed first, the answer is 0. However, if the 0 is the denominator, or listed second, right? That answer is undefined, and I'm going to do my best to explain why using pizza. So here we go. Let's talk about this one first. If I've got 0 pizzas and 5 people, each person gets 0 pizza, right? Because there's no pizzas. But what if we have 5 pizzas, but there's no people, right? So I'm in a classroom right now. What if I had 5 pizzas sitting on that desk and I walk out the door, no one's in the classroom? Well, that don't even make sense, right? That's undefined. It's literally stupid. So we can't take a number and divide it by 0. That answer is simply undefined. Okay, so this is something you're going to have to memorize. So as you're going through the homework, you're going to get a question that says some number divided by 0, and the answer is undefined. You'll make sure that you type undefined in the blank. Okay, we're going to move on to our next question. All right, read the directions. The directions say find the reciprocal of the following fraction. Well, the reciprocal, you don't have to switch it. The reciprocal, remember, just simply means to flip it upside down. So if we're going to be flipping this thing upside down, I'm going to click on the keypad. I'm going to click on the fraction button right here. All right, and let me type the 5 and over 3. So there it is. 5 over 3 is the reciprocal, and let's practice. One thing I like about Hawks is that it does give you a little bit of positive feedback, sometimes negative feedback too. All right, find the quotient reduced to lowest terms. 38/15, I'm writing it down so that we can work it together, divided by 19/24. And all right, so here's our example. Remember, what do we do with division? We change it to multiplication, and we take the second fraction and flip it upside down. So let's do that. So keep the first fraction identical to the way it was to begin with. Change division to multiplication and flip, or reciprocate is the correct vocabulary, the second fraction. All right, so let's go ahead and do our reducing now. 38 is divisible by 2 and 19. Wait a minute, we got 19 over here, don't we? So 38 and 19 can reduce, both of them by 19. 38 divided by 19 is 2. 19 divided by 19 is 1. Notice that we reduce by the same number each time, okay? Let's see if anything else can reduce. The 2 does not share anything in common with 15, which is 3 times 5. The 24, however, does with the 15. 24 and 15 can both be divided by 3. Because 24 divided by 3 is 8, and 15 divided by 3 is 5. So what's left here? Well, let's see. 2 fifths times 8 over 1. Awesome. Remember, the 2 and the 8 cannot reduce because they're both in the numerator. One has to be numerator, the other has to be denominator. Doesn't matter if it's to the left or the right, but it has to be the denominator. Now we can just multiply straight across. So we have 2 times 8, which is 16, and we have 5 times 1, which is 5, and our final answer is 16 fifths. This is called an improper fraction. It's not actually part of the lesson, but I think it's valuable to know that vocabulary. An improper fraction occurs when the numerator is larger than the denominator. These are the ones that can be converted to mixed numbers. I don't know if you remember that from back in the day. Let's move on to our next example. All right, so this one's going to be a little bit more interesting. 12 25ths times 45 35ths times 55 20ths. All right, so we need to do the same thing here. We need to reduce. All right, there it is. Sometimes these things look a little intimidating, but let's reduce what we can. Okay, let's recognize a few things. I'm going to start. You can start wherever you want. I'm going to start with the 55. Okay, so this is how I see it. 55 is the largest number, so I'm going to try to bring that thing down as much as I can. 55 is 5 times 11. Do any of these numbers divide by 5? Yes, all 3 of them do, but I can't use all 3 of them. I got to pick one. Okay, I'm going to pick this one. Why? Because it's the biggest of the 3, I guess. I don't know. There's no real reason. Pick whichever one you want. 55 and 35 both reduce by 5. 55 divided by 5 is 11, and 35 divided by 5 is 7. All right, so let's do another reduction. First of all, none of these 3 divide by 11, and that's okay. Let's take this 45 now. 45 is 3 times 15 or 5 times 9. Let's see if any of those numbers, 3, 15, 5, or 9, can be divided into any one of these 3 numbers. Well, 5 divides here and here. I'm going to choose this one. 45 and 25. 45 divides by 5 to make 9. 25 divides by 5 to make 5. All right, now it's really starting to get jumbled up. So I'm going to do one more, but I'm going to change my color so that it's easy to see it. Okay. 9 is 3 times 3. None of these numbers have 3 that can go into them. 12 is 2 times 6 or 3 times 4. There's 5 doesn't have a 2, a 3, a 6, or a 4. 2, 6, 3, or 4. It's neither does 7, but 20 can be divided by 2, but it could also be divided by 4. Let's go with the 4. 12 reduces and 20 reduces by 4 to make 3 and 5. Okay. Now let's do one more quick scan. But before we do, I'm going to rewrite this thing. So I got 3/5 now times 9/7 times 11/5. Okay. Remember, the 5s can't reduce. They can't reduce because they're both in the denominator. The 3 and the 5, 7, none of them can reduce with the 3. None of these can reduce with the 9. None of them can reduce with the 11. So we're finished reducing. Now we just have to multiply. So we multiply across 3 times 9. Take that answer, which is 27, times 11. $297, sorry, took me a little while. I apologize. All right, over 5 times 7, which is 35, times 5, which is 175, I think. I might need to get my calculator, y'all. Hold on a second. Got my calculator now. And of course, oh, there it is. All right. So double checking, 3 times 9 times 11. Yep, that was right. 5 times 7 times 5. Hey, look at me, boy. I'm doing good today. This is our final answer. Okay, so review. Just take a moment, digest what just happened, okay? Let me refresh one more time. We did some reducing. I started with the 55. I chose it for no particular reason, except that it's the biggest number, so I wanted to get rid of it. So I reduced the 55 with any one of these 3 because they all are also divisible by 5. The 35 is the one I chose. Then I took the 45 and reduced it here. Nope, here. And I got 9 and 5. Then I reduced these 2 and got the 3 and the 5. I rewrote it so I could see it clearly, right? Because it becomes a jumbled mess. And that's my final answer over here after multiplying. Remember that once you finish reducing, you can multiply straight across. Now, here's the question. Could we have, in the beginning, just multiplied all the numbers on the top and then all the numbers on the bottom and gotten a fraction of 2 big numbers? Yes, of course you could have. It would have been a little bit of a headache to reduce that, but that's okay. You could have still done it that way. All right, let's go on to our next example. Got me? I want to do one of each type of example. All right, so we already did one like this. In this case, you can't reduce. 5 doesn't reduce with either the 8 or the 2, and of course 1 doesn't, so you would just multiply straight across. So I'm going to go ahead and hit my fraction line. 5 divided by 16, and that's our answer. Next question. All right, what do we do here? Well, 11/42 divided by 11/42. Go ahead and switch it, please. 11/42 divided by 11/42. Wait a minute. Why didn't I write it like they did? Well, remember, division switches to multiplication, then we have to reciprocate the second fraction. So let's go ahead and solve this thing. We can multiply straight across, but what would happen then? Wouldn't we get the same number on top and bottom? So anything divided by itself is 1. The other way to look at it is I can reduce the 11s to make 1. And I can also reduce the 42s to get 1. So we have 1 over 1 times 1 over 1, which is just 1. You see that? All right, so let's continue. Might have to pick up the pace a little bit. Y'all, I'm experimenting. This is my first time ever doing this. Switch over. this whole video conference thing, or video lecture situation. All right, so we're gonna skip this one because we just put it on the answer. It's just one, right? We've done one like this already. Find 1/9 of 1/5. So we just multiply those two. Again, here we would simply multiply, change division to multiplication, and flip the second fraction upside down. What's anything times 0? 0. We did one like this a while ago. I think it's valuable that we do this one. Now listen, it's telling me that I have less than 2 minutes, probably closer to only 1 minute now. So I'm gonna work this problem out fairly quickly. Hold on, time. 8/15 times 40 over 45 times 55 over 10. Switching. All right, I'm going to work it out fairly quickly because I'm running out of time. So I'm going to reduce the 55 and the 45 can both reduce by 5 to make 11 and 9. Because 5 times 9 is 45. Let's see, the 40 can reduce with the 10 to make 4 and 1. They can both reduce by 10. 15 can reduce with none of those, and neither can 9. So let's rewrite it. 8/15 times 4/9 times 11 over 1. Let's see what we got. 8 times 4, 11 times 11 is 352. Remember, we multiply straight across. 15 times 9 times 1 is 135, and that's our final answer. All right, we're going to switch back over so we can look at the last example and pray and hope that we don't run out of time. Switching, thank you very much. Last example says 6 divided by 24/49. We write that down real quick. All right, let's get it. 6 divided by 24, what was it again? Hold on, I got it. 49s, 24/49. Remember, we need to put this over 1 anytime we have a whole number. So now it's 6 over 1 times reciprocal 49 over 24. Reduce what we can. 24 and 6 reduced by 6 to make 1 and 4. So our final answer, we multiply across 1 times 49 and 1 times 4. All right, so that's the end of our lesson. Thank you very much.